So in this video we're going to talk a little bit about the forces acting on a magnetic field. If you have a charge moving through a field, you will have a force. We need to calculate a few things. We need to, well, first of all, calculate the force itself. In order to do that, we need to know the charge, the speed, and the field. If there is an angle, that will also affect it, so we can use the sine of the angle, and this takes us to our force formula. F equals QVB sine theta. If it's perpendicular, sine of 90, which is good, sine of 90 is 1, you can just ignore it. You can just write QVB only, because sine of 90 is 1, doesn't make a difference. If it's parallel, that's a problem. If there's a parallel, then that means the angle is 0. The sine of 0 is simply 0. That means the whole thing, there will be no force. So essentially, there is no force if there is no charge. If it is stationary, not moving at all, that's a trick that you might find in an exam. And if there is no magnetic field, there will be no force in those cases. Okay, if you want to find the value of this, you can go ahead and solve a question like this. I can quickly try that with you right now. Probably don't have my calculator to hand, but we can check this here. If I wanted to find the force of each one, you can do F equals QVB sine of my angle. So Q is a proton. We know protons 1.6 times 10 to the minus 19. We have memorized this because we've used it so many times. Multiplied by the speed it's moving at, which is right here, 5 times 10 to the power of 6. Multiply that by B, the magnetic field, which we have here, Tesla's, 12. And the angle we have is 30. So I'll times that by sine of 30. And you put that in your calculator, you will get your answer. 90 degrees, exactly the same numbers, you put everything in, but sine 90, and you will get a new answer. Over here, the angle is 0, so there is no need to even bother trying to calculate. The force will be 0. So there are other possible units for T. If you rearrange that formula that we have over here, F equals QVB, change it to get B, you can have these formulas here. This one we'll deal with later on. This is when we're using different formula, but this one is the one that we will deal with right now. You have your F equals QVB. Changing that to get B, I'll do B equals, take these two to the other side, F over Q and V. I'll divide both sides by Q and V. And the unit for F we know is newtons, and the unit for this one, Q, is coulombs, and the unit of V is meters per second. Okay, this comes from the lib formula. We'll deal with that when we come across that one. Right hand rule, so we can use the right hand rule to figure out the direction of the force that it's moving in. We spent a lot of time working on this as well. Our direction looked like this. We're using the rule. For protons we will use the right hand. For electrons we would use the left hand. So let's bring this out over here. So using my proton over here, I can say that my V will be the direction of my thumb. I will say my B is the direction of my field, and my F is the direction of my force. So in this case, we have the B pointing towards me. I have my V going to the right. My force is acting down. Let's try one more over here. Let's say that we have my B pointing to the left, so I'll take my hand and I will point it to the left, and my V is pointing up like this. V is up, and for my proton it should be like this. So B to the left, V is up. This is out of the page. Out of the page. Very nice. Last one over here on the right. Let's see what's happening here. B is pointing in, so my fingers will point away from me. Thumb is pointing like this, and then my middle finger is pointing to the left. If you have an electron, we will use the left hand. That's the only time we're ever going to use our left hand, is if we have an electron moving. If you use the right hand, it will be the opposite. If the right hand says left, it will be to the right. Or you can just use the left hand, and you'll get the same answer. Okay, so looking at this here, 3 objects enter a field. You have a negative, a positive, and a neutral charge. Neutral we know does not get affected, so it will go straight. If we have a fuel pointing into the page, you can see that the B is going in and all three are going up to start with, like this. The force on my positive charge is pushing me to the left. The force on my negative charge will be the opposite. It will push me to the right. You can check with the left hand on that because it's a negative.